All right, so if you have some sequence, so remember that just means it's a list of numbers, then the sum the summation, which using sigma notation, we'll just say summation over n of a sub n. So it, n from, I'll say, I'm going to bad notation, but say start, and it's a list, so it goes on forever. Start to infinity is called a series. An R. So in other words, a series is an sum over terms in a sequence. So that's the definition. So I'll say that in parentheses, a series is a sum over terms coming from a sequence, terms in a sequence. And so, of course, what do we mean by sum? Can we actually sum up these things, and can we actually get a number if we do that? But at the moment, it's just a notational thing. So it's a sum over terms in a sequence. So if we can sum them up, we have to be very careful. The reason we need it to be a sequence is because when we're dealing with infinite summations, the order of the terms is very important. This is not like ordinary sum. If you're adding up 10 items, then you can rearrange the order. It's irrelevant. If you're summing up an infinite number of items, then the order is very, very important. And so there has to be a certain order with which you add things up. Okay, so now what does it mean to actually be able to sum up everything? So what does this actually mean? So just schematically, so if an, so this isn't a legitimate example, it's just a schematic example, but say an, it's a list of numbers, and let's say we start with what I'll call the 0th term, so it's this, the first number is a0, the next number is a1, the next number is a2, and so it's a sequence, so this list goes on forever. Then this summation, then the series will be summing over n goes from 0 to infinity of an. So that just means a0 plus a1 plus a2 plus a3, and this goes on forever. But we don't have to start at an. We could start, we don't have to start at 0. We could start at, we could say summation n goes from 2 to infinity of an. Now you start with a2, and then you have a3, and you have a4. And these are both series because they're these infinite sums. So these are two different examples of series, even though they're obtained from essentially the same sequence. Okay, so so here's another definition. Again, given a sequence, we get a new sequence. So let Sn be defined as summation from k, I'll just say start, up to n of a sub n. So what does this look like? So you're summing up to n. So this is called the partial sum. This is called the nth partial sum. Now, technically speaking, the nth partial sum should be the first n terms. So I shouldn't really say from start to n. I should say to start to start plus n, if that makes sense. So for example, let's say we have a1, a2, a3, a4 is our sequence, then S1 would just be A1. S2 would be A1 plus A2. S3 would be A1 plus A2 plus A3. Okay? And since these are finite sums, since each Sn is a finite sum, each Sn is a number. Okay, so for example, you can add up one number, you can add up two numbers, you get a number, add up three numbers, and so forth. And so then we can actually talk about whether a sequence converges or not. So we say, let me change colors here, we say the series summation n, I'll just say, we'll start from 1 to infinity, but it doesn't really matter where you start, of an, we say that it converges to L, so that's the, sorry, I left off the word, we say the series, so this is an expression we say, the series converges to L, if what we do is we take the limit as n goes to infinity of these partial summations. So let's expand that out for a second. So you're taking the limit as n goes to infinity of the partial sums. You're starting from k, say it goes from 1 up to n, of your a sub k's. So it's similar to indefinite integrals. So if this limit is equal to L. Okay, and we denote this, and we denote this, and we write the summation, n goes from 1 to infinity, of a sub n is equal to L. So we can formally just write this summation, a number plus a number plus a number plus a number on forever, but to actually, what does it mean if we can actually add them up? So converge means we can add them up. So that's the term here. So converge means we can add them up, and so converge means we can add everything up. Putting that in quotes because it's still an infinite number of things. So you can ask about what does that mean to add up an infinite number of things, and of course formally it's defined as taking a limit. So we can actually, so what does it mean? So sorry, it's kind of confusing, but what does this mean here? This means we're adding up an infinite number of things and we get some number. But formally, how is that number defined? Well, it's defined in the line directly above it. It's defined over here. That means that you take the limit over the finite sums. So it's impossible to add up an infinite number of terms, but you add up the first 10 terms, that gives you a number. Then you add up the first 100 terms, that gives you another number. You add up the first 1,000 terms, that gives you another number. Add up the first billion terms, a billion plus one terms, trillion terms, blah, blah. As long as it's a finite number of terms, you can add them up. And so you just want that these partial sums ultimately converge to some number. And if it does, then we say that the sum of all the infinite summation is equal to what it is. So converge means we can add everything up, and so that's the term here. A series converges, and otherwise, if a series does not converge, then we say it diverges. So these are exclusive conditions. Either the series converges or it diverges. And so later on we'll talk about how do we determine if a series converges or diverges.